Starting back in the day, the first iteration of this, the earliest enterprise access points were similar to consumer devices with the bonus of some enhanced feature sets, but these access points were typically referred to as autonomous and didn't have a control plane and really no management either. These access points are out of the question for today's mobility needs because we realized as an industry that we need control, and that's required to enable a sustainable model for enterprise Wi-Fi. So moving on to the second iteration here, this is around 2003. That's when the Wireless Lan Controller, which is a hardware platform that fully centralized the WLAN management control plane and the data plane, hence the name controller, was introduced. The WLAN controller was developed to serve the purpose of a central brain, and then those thin access points served effectively as radios or antennas separated from the brain by an Ethernet cable. In an ideal world, we would have placed the intelligence directly into the access points even back then. However, as the inventor of the controller, who was Bob O'Hara, he stated it would have been economically impossible to do so with the cost of chipsets in that day, so we were restricted. The controller was a detour, but an acceptable one, because it was the right tool for the problems at that time. And the controllers eased the management and security headaches that non-pervasive networks comprised of autonomous access points would cause. Today, however, with the reliance on Wi-Fi and expanding networks and increased performance requirements, the centralized model has severe architectural limitations, including bottleneck issues and scalability, even resiliency concerns. So we moved on to number 3 as an industry. And again, as Wi-Fi started to become a contender for the primary access medium, and then recognizing some of the shortfalls of the physical, fully centralized controller model, WLAN vendors had to reevaluate their architecture and began to adapt their controllers through virtualization or portfolio integration. This model also did place some of the intelligence back into the access points, which is a good thing, along with the introduction of local data forwarding rather than sending every packet back to the controller. And in smaller deployments, an access point within a cluster could also act as a controller for a group of local APs. So while these hybrid models do offer increased deployment flexibility, there are some trade-offs to be aware of with this architecture as well. Solutions that integrated controller functionality into the access points themselves would also struggle over a certain number of connected access points, given a single access point has nowhere near the processing power of a dedicated appliance, whether that be physical or virtual. And hybrid solutions are still used by many vendors today because they're bound to their legacy architecture, because they've invested so heavily in that, but most are starting to move away from that hybrid model. And as Wi-Fi continued to gain popularity, and soon, the controller was on the move again, this time to the cloud, with vendors able to push more intelligence into the access points themselves. The cloud platform was introduced to serve both as a controller and also a management solution. Commercially, this model works for quite a few people. However, technically there are still some limitations. Ultimately, the solution still utilizes a controller, and the access points still depend on that controller for certain functions. Therefore, if connectivity is lost between the two, then organizations will face an impacted service, from user connectivity to security policies and enforcement. And additionally, although organizations typically outright purchase their hardware, so their access points, if they forget to renew their controller license or support, then their wireless network will cease to operate, which is obviously a major pain point for most organizations that rely on wireless. So if you are evaluating a solution of this kind, or looking at a prospect that's evaluating a solution of this kind, it's imperative that that organization checks with the vendors exactly what will happen if 1, access points lose connectivity to the cloud, and 2, what happens if the controller or cloud license expires. So keep that in mind. And then the last solution we have up here on the slide is distributed control. Distributed control is ultimately what the industry was striving for back in 2003 and what it has achieved today by completely eliminating the need for a controller. and instead creating a shared control plane through a protocol known as cooperative control, which is similar to the routing and switching control protocols that we discussed previously. With access points able to fully accommodate both control and data planes, the cloud would only be utilized for centralized management. And through distributed control, the intelligence, which is the control plane, is all placed into the access points themselves, and then the management remains centralized for ease of administration. The concept of fully distributed control is a principle, again, that the inventor of the controller had desired to achieve. However, it was only made possible years later through the observance of Moore's law, which is that technology gets cheaper and it gets smaller as the years go by. So distributed control combined with cloud networking increases the speed, scale, and resiliency within the network without sacrificing the centralized design, deployment, and support of a truly enterprise-grade wireless network.